Hello. Click some music. Oh, Snailfish 2021. So, like, separated by column, we have to parse that, right? Only had plus and multiply. A left-right alignment number within X problem can be ignored. That means in part 2, they probably cannot be ignored. No comments so far. So we get a line. Mm. So let's put some comment first. open. Gonna do this right strip, Python, mutual link. So there's Python right strip, remove the line. Okay. So we still need this because we don't know if part two they're gonna do like space stuff, right? So we kind of still want to keep the space. And the only thing we know here is um, if we see a column, then we know that that's the separator of the thing. So like one space here with this. This one has two space. This one have one space. Mm, one thing we know for sure, if we see these operator, then we probably want to save them in operators because we want to apply, we later probably, let's say we figure out this array here, we just apply this thing to this, right? So I want to say that if line 0 is in plus or multiply, then operators basically go to line strip line dot split, right, by, yeah, right. So Right, for sure. Otherwise, we would need to parse this. But we don't know if the column is there until we parse all this. Right? So let's say we get this line. We basically say that if the characters here is all the space, then we know from the previous to before this will be the numbers, right? So that means probably should save the line first, right? So let's do this not in here. This is operands lines. Otherwise, so this is shipping here. This will be applying or like the operators to each of the, let's call this, what they call this, problem. The problem here, right? So each of the problem. Okay, so now still have to do line, right? Here we go. So this means that, so like for each, if we found the column here, right? That means we have to loop, and probably luckily the line number here is for each of the line. So let's call this, the beginning here is I, the end here is J, right? So let's actually make it begin and end, and then basically L, almost BBL. So begin will start with 0, and will start with 0, length of line 0, because we know that we have to loop from here to here. So basically while the n is less than the length, and then for sure a plus equal 1, right? We say that if the lines uh, will be, so we loop through this, if say we need to say like if w- we need to, okay, so let's not comment that because I already said that. Let's try to visualize that. So now we have each line. We can check that if lines at 0, right? So let's do line 0 with us these characters here. Up E equal new line space. Then we want a count for each of the line, right? And so for space count equal to, we loop from from this to the end. So we say for AI in range of, starting with 1 here because we found here's 0. So 1 to the length of lines, right? And then we want to say that, so let's call this 1, and then we want to say that if lines at I and then N, right? Start and end, right? So let's call this S so that is easier, right? Equal also, right? We count number of columns. So basically number of column equal to the number of -1, right? So like we count from here to here. So we say be we can do length. We do sum too. We want space count equal to length of line -1. Right. So this mean column of space found from B from, so basically B to not including E, right, is the number. Right, so basically now we found the problem. You got a pen, right? So we want to take this 1 2 3 4 5 6 here. So will be for, let's call this start like before, right? In range of length, right? So this will be lines of S uh, so it's from begin, right, to end, right? Okay, so let's print out and see if we so far what we did is correct. Okay, so we do print operators, print problem. Okay, so return 0 for now. Day 6. Okay, we go here. And day 6. So basically we saying Python day 6.py. So we have 1, 2, 3. Is that correct? Yep. Space 45. Space 6. Something wrong with the second one here. Oh, so after we get the thing, we also need to increase our E here, right? Then we skip the E because E is space here, right? So, right, so we have 1, 2, 3, correct? Space 45. Um, space 6, good. 328. We want 64 space, yep. And then 98 space. Yes, the reason we do all this is they said right here, the can be ignored, right? That means in part 2 it probably cannot be ignored. So we want to preserve that. And because they said separate by full column, so we did that. So space 51, good. 387, 215. Um, what happened to the last one here? Hmm. What is the character here? Isn't that space? Hmm. Well, the line. Wait, let's also print the line here. What happened to the last one? Oh, it has the new line here. So we also want to do this, right? Um, so let make a function. So we can do it here because we want access to problems, lines, right? So let's call this um, because not only is it space, it's also new line, as we can see here, right? So we want this same thing here. So let's call this function, we don't know the name yet, let's just, for the sake of that, so we want this, right? So we want to match the delimiter here and do this. So if this is true, then we return true, otherwise return false, right? So we want to say that and basically let's call this, what do we call this, what should be a good name here, also the E here, right? So basically we want the same logic here, right? But this one will be new line, right? Right, so we want to take out this into a function. That means this function basically should also live here, right? Because need access to B and E here, right? There's B and E here, right? So basically you can do here, right? Um so basically we want the, let's call this column found, delimiter found, right? So if it is this and column delimiter found by a space, right? So then we would do this, yeah, yeah, one, So basically we can do this way. Return this, go to right, something like that. Right, so what is going on? No insert. Oh, this is because of word wrap. There we go. Okay, so basically if we found that, then we do this. Right, we also want to do this. This is new line. Right, so yeah, so column of new line here. Right, so something like that. We probably want to abstract this out as well. So we want this, right? Right here. Or the same thing. Yep, so that we don't repeat the logic. Just run our parsing so far and see. Okay, so we have, whoa. Column turn. Oh, this one, right? We have some duplicate stuff here. Is it? Oh, it's correct, right? Oh, -1. Let's move. Convert. Would be -1, right? Because we count from 1. So something like that. Let's check our function real quick. So we have 123, 45, 6, 388, 328, 65 space, 64 space, 98 space, yep, space 51, 387, correct, 215, yep, and then 64 space, 28, 3, 50. Okay, good. So now we got all the problem, right? So we can apply outside the loop, let's say, right? So the next question we want to know is, does space 45 integer equal space 45. Does it give us 45 or does, or like we have what, we have another space here, or like this many? It does. So the int function in Python actually strip out the space. Good. So that means we just need to integer this and then apply them together, right? So now we do, it is correct. So now we do for I in range of, then operators, this keyword operator equal operator i's. We want to apply this operator in we want to apply this operator with all the problem that we have here in Python. So this is the use case for the reduce function. So let's say Python reduce apply example. So we have, we call the reduce and we pass a lambda. So here we, and we pass a number. So we're gonna say reduce lambda xy, and this is where we apply operators here between x and y and operators, right? So then we applied on problems I, right? Now we need to write the apply operators, right? Yep, between operators x and y, right? So we only have plus and minus, right? So I'm gonna do if operators equal plus, and we return integer x plus integer y, because we know that integer with all the space can convert correctly, hopefully, then should be fine. And then we do, so assuming plus and star only, so we just do the rest is just star, right? Okay. They said plus or multiply, so then we can just return integer of x multiply integer of y. What? Okay. Oh, okay. So what is it? From func to from func to import reduce. Okay. So basically, we make a product out of these, we sum them, right? So for every two element, we apply this, and we should have called this operand, but that's fine because I put the comment here. So yeah, so this is what do they want? Sum them together, right? So we actually can just do list comprehension, right? Return sum. Uh, this will be operators I for I in range, right? Operator, right? So we do oh operators. So we do the same thing here. This reduce to, right? Is that correct? So so this is actually this, right? So we loop through the operators. We apply the operator for all the array. That means we have to reduce to the problem I, right? So that's it, right? Guess so. Oh, let's see. Test part. We have file name, and then we have expected. The actual equal file name, right? We assert. God would do expected, right? So then we'll do this, right? So what they say here. Okay, let's see. I think we're good. What did we print here? Why does it still print something? What is this line? CLS? Okay. What? What is this extra line here? Whatever. We didn't print anything. Okay. So now we get our puzzle. Okay, so let's see. Okay, so this is our number. That's quite a big number. So is Python, this look like a 64-bit number, okay? Is Python in 64-bit? Okay, so it depends on system. So how to print in size in Python? What is this? Yeah, it's a by in pi int object, right? So uh Python, what is it? Okay, so we do import sys dot max size. It looked like a 64-bit for me. Yeah, so like 2 to the 64, right? Or 63, right? No, 63 minus 1, right? Is that equal to sys max size? Yep. So in my system, it's 64-bit. So I don't have to do big in or something, right? Okay, let's submit this number. Hope for the best. Oh, yes. We'll commit this. Yeah, I have a lot of event of code that I didn't go back to. We'll try to do that. Be Python. Will be, what is the format that we do? Just do day part, okay? The day 6, part 1. Continue to part 2. Okay, now what they saying? What are they even saying here? So we have to read from right to left. So 4 here. 4, 3, 1. 6, 2, 3, right? And then 1 to the 5. 5, 8, 1. 3, 2. Okay, so this actually count as, so basically we take the number by, if we see space, we just concatenate them, right? So okay, so we loop from the end 3, 5, 6, and then 2, 4 something, 1 something something, right? Right. So let's call this function part function, right? So we refactor them. Part 1. So Oh, so the way we get number are different by, so we still loop to them and we still applying operators, but somehow if we convert the problem differently, then we should be good, right? So the part one we basically take for granted 1 2 3 4 5 6, whatever, right? So as long as we can produce another problem. So okay, so basically as long as we can transform this, so then part one problem, right, so and then part one basically is the identity function, right? Whatever the problem, we return them like this, right? So right, so part two, so just for the sake of, so basically the part function here would just return what it is, because the we parse the parse one in whatever the format is expected already. So yeah, so then we need to part the part here, right? So now we make sure everything still works, right? Oh, sorry, wrong one. Day 6. Yep, it still works. So now we just need to convert the problem in part 2 differently, right? So yeah, so we got 1 2 3. Let's just give some example here. Part 1 we have 1 2 3, space 4 5, space 6, right? So we want it to become 3 5 6, um 24, and what is it, 3 5 6 24, and then 1, right? So basically 3 5 6 24 space and then 1 space, and then we know that integer with space should be fine, right? Something like that. So now let me check one thing. Let me check the stream setting. Okay, still good. Okay, let's switch some music, by the way. Let's do this. Oh, this one sounds good. Let's switch up some music. Okay, now we're back to this. So we basically loop, right? We loop and we take each character, right? 3, 5, 6, right? So we basically want to L equal to len of whatever, right? Because now all of this is already justified, so we just pick one. Problem 0. We say that y at y greater than or equals 0, right? And then we do problem, let's call this transform problem. What they call this? Right to left problem. So let's call this right problem. Right, and then we just return right problem, right? So now um hmm, this song kicking, man. Then now we have to loop from we take one of each here, right? For AI in range of len problem. Okay, so actually we can do for C in for S in problem, right? So for each problem we take the last one, right? Which is the L one, right? So -1, right? We take the right problem, right? Uh, let's do this. S equal, so basically S plus equal N at L, right? So we have, so L first become this character 0, 1, 2. We take 2 each, right? Okay. Or we can just do right problem append, do list comprehension here, right? Will be NL, right? So then we do join. Yep, that should do it. Right. So let's do a print problem become right problem. Yep. So now we do this. be part 2. We're expecting this numbers. Oh, will be this. Okay, seems like correct. 1, 2, 3, 3, 5, 6, 1. Good. 3, 28, 64, 98. So be like 8.248. I think it's correct. Okay. Let's do this one. This is our number. Is that correct? Yep. Let's commit this. So day 6 is done. Let's take some break. Okay. Let me go restroom real quick. Get some water as well. Be right back. Be right back. Okay, back now. Pick some music. This music been good. Okay, so we have 7, 8, 9, and 3 still stuck here. Part 2. Do 7. Do A7. Oh man. Let's check social media real quick. Don't know, maybe we might have to do tomorrow, maybe. To do tomorrow, maybe. But let's see. Kind of sleepy right now. Let's just set up stuff first. Let's switch the music. Oh man, that's a lot of description. What is Tachyon? Oh, faster than light. to get this, it basically go left and right. So look like a graph traversal problem. Okay, so it keep doing that, and how many times will the beam be split? Right, so from this position, right, the next move is basically all the next move will be the splitter in the next position will be splitter in the same y-axis. I no, same x-axis, and then uh, when you are here, you produce two more, and we do the same thing, right? Right. So look like a graph problem for me. We can do depth first search. We go this, 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 this. Go here, we go here. So basically, if we see any, so 1, 2, 3, 4, 5, 6, right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, something hit, right? So like in this case, do we need to count the number of time we hit the splitter, right? So basically we hit this, go here, and if the next time we come back here, we don't count it. Right? So yeah, let's try that. I don't know. So file name, right? So yeah, so with open, and the condition is basically saying that um, if we found nothing to go to, that means that the end we would not produce any new move, right? So we first need to do this sample dot. Also kind of sleepy now. Hopefully that approach works so that I can go to sleep. Right. So basically you have to read this. um, so for line in and we do probably have maybe splitter as a set of position, right? And we need a the start, right? So let's call it start x. That's why start x, right? Right, so basically for x in line strip if let's do characters enumerate, right? So we say that if the character is the s, then the sy go to, so let's also count the 0, so yb plus equal 1, so this is yb x, right? And if the character is equal to, what is this one, and basically do we want a splitter by this? Let's do 2 by the x position. Do splitter dot add be ybx. So also do equal to right. So this is the boundary. Y okay, and we also do splitter by x. Oh, we need to check, so this should be actually a dictionary. Okay, so at x quite sleepy right now. We want to say if x not in splitter by x, and splitter by x equal to, let's do an array here, okay, and then we do pen, right? So we start with, right? So just want to confirm that we got everything correctly. We need a function to debug that. Let's call this debug. debug grid. So basically we have b splitter, and we have stat y stat x. Okay, so for y in range of yb, range of okay. And so we say that if yx in splitter, then basically we have a line here. We do line plus equal to a caret here, and then elif y go to sy sec, then basically we say s the y line plus equal dot, we will print the line, right? So let's do a debug grid. Sy sx yb yx x ybxb splitter, right? Let's do that. Part a right, day 7 Python. What? Append. Oh, tuple. Okay, let's see if we have correct. So 0 1 2 3 0 1 2 0 1 2 3 4 5 6 7 7 1. Right, so let's also do and then we do ybxb, right? Right, so 0 7 16 15. What? Yep, there was 0 to 17, right? So 1 to 16, that means 0 1 wait 0 1 2 3 4 5. So this is 16 15. 0 15. Oh, 16, yep. And also 0 to column 15. So 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Yep, so that is correct. So now we need to do a depth first search. Right, so we do until we go to the end. So we have this. So we say that if so we start, and then the next position we should look at is we look at splitter by x. Okay, so first, if yx in splitters, then we do deficit. That means we gotta do want to add it to the front, right? So plus q. So we need a function. So from this position we want to go from so y for y in be like same position x minus 1, go left, and then we go right, and do we even need to check the boundary? Yeah, we do. So no, let's look at the sample input here. Day7.pxt. So look like if we hit this, right, we never go out the boundary. Okay, so we don't need to check the boundary, right? So this is when if x in splitter by x, right? So then we need to find, like, we start here, the next position will be this, and then if we start here, next will be this. So we need to find all the one that greater than the current one, greater y, right? So find next splitter greater than current y, right? So that means q go to plus q, right? So this will be splitter by x, take the x, give us all the ya for So we let's call this candidate splitters equal to and we wanna if y greater than current y, right? So this will be candidate splitter, right? Okay. The question here is if, right? Then do this. Uh, if there's no candidate, then probably fine, right? Otherwise, here mean we got to the end. We got to the end of the manifold, right? And also here is we got to the end of the manifold, right? Do we need to do anything? Now, what does the question even ask here? So it asks the number of split. Split a total of 21 times. So I go here, I split 1, 2. Let's look at this and zoom in. What are they asking? So we go here, split 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Wait, what is this then? Also sleepy right now, but let's see. What is the beam even? Do we need to count? So we do this, we go left like this. 1, 2, so how many times would the beam be split? Does that mean, does it, what? What does it even say here? that mean the number of uh, bean that we hit? Uh, Probably need coffee in the office tomorrow. But let's give this another 10 minutes, right? So we have the logic for producing the move. We just don't know what is it asking him. How many times would the bean be split? Split one here, hit this split two here. Guys, I'm so sleepy right now. Give it another 5 minutes. Mm. I'm so sleepy right now. Maybe I'll have to do this tomorrow, part two tomorrow. But we finished day 6 today though. We still have day 7. Oof. So tomorrow, if things going well, we can do 7, 8. It's still 9 here. Uh, I'm gonna call it a day now. We have to sleep, go to work tomorrow. And if I can go home early tomorrow, then I can continue this. If not, maybe the day after. But yeah, let's call it a day here.